Okay, welcome to this weekly. This time we're going to focus on systems of inequalities, and you will need a piece of graph paper for question number 3. So the big ideas that I would like to focus on to start with are as follows. A linear inequality, just talking about one, describes a region of the coordinate plane that has a boundary line. And so every point in that region is a solution of the inequality. And so if you graphed an inequality and shaded one side or the other, depending on the inequality, any point in the shaded region is considered to be in that bounded area. The boundary line would be your inequality, and so it would be considered a solution to that that linear inequality. Now, the next point here that we're going to make, though, is that if you have more than one inequality, together it would form a system of linear inequalities. And so when you have this case, then you're going to have more than one boundary line. And so when you start shading your solution set, you're going to have overlapping regions. And anywhere that you have an overlapping region of where you've shaded, that's the area that is bound that is going to be considered your solution set. So a solution of a system of linear inequalities makes each inequality in the system true. It's going to be located in the overlapping shaded region on a graph. And if you were to plug in each an ordered pair into each inequality would be true. So you can have more than one solution for a system of inequalities. So graphing a linear inequality, step 1. I know it does say here to change the inequality sign to an equal sign. You don't have to do that. You can leave it as an inequality if you would like to. But then it says to graph it. What you will do is graph it like you would a normal linear equation. Okay, so just treat it as y equals mx plus b, but you don't need to change to an equal sign. Okay. Now it says if there is a bar beneath the inequality symbol, that's going to be either in greater than or less than or equal to. Then you're going to have a solid line. So we know that. All right. So anytime you have this or this, you'll have a solid line, a solid circle on a number line, and a solid line when you graph. Okay. So whenever you don't have that bar beneath it, you're going to have an open circle on a number line, and you're going to have dashed lines when you graph. Okay, so that's the big difference there. Okay, so make sure that you've got dashed little lines. Okay. Step 2, that's where it says to restore it back to an inequality symbol. If you never changed it in the first place, you don't need to worry about that. But this is where we were talking about test points, and that's where you were talking about how do you graph these lines and shade on the correct side. So we always picked in class, we picked 0, 0. As long as the line doesn't go through 0, 0, that's what I would choose because it's probably the easiest. A lot of things will cancel out. So it says, however, if the boundary line or the equation passes through 0, 0, choose something else. Okay, so you have an xy ordered pair, right? You have x and y in as your test point. So you would plug in 0 for x and 0 for y, and it says if the test point makes the inequality true, then that's the side that you would shade. If the test point makes it false, shade the other side of the line that you graphed. Okay, so those are your big ideas. All right, here comes our first example. So in example 1, it says, where is the solution to the system of inequalities? So this has already been graphed for us. It says, what is one point that lies in the solution set that is graphed below? Well, we need to make sure that we are looking right in this area here. All right, that's the area that we would focus on, and that's because it's the overlapping region. Just be careful. Don't choose anything on this line here, because that is a less than or a greater than symbol. There's no equal to. So the solution can't be on that part of the line. So 7, 0 is looking at 1, 2, 3, 4, 5, 6, 7. Looks like right there. 0, 7 is going to be way up here. All right. 3, 0 is going to be right here, right there. And negative 3, 5 is going to be over in this area. The only one that works here is going to be 7, 0. That's choice A. And that is our answer. So that takes care of example 1. Please stay tuned for the question that follows. Okay, let's look at this next example. It says which system of inequalities is shown. So basically we have our system here, and we're going to graph both of these. We'll see which one is shown. First of all, looks like we have greater than or less than or equal to symbols, so everything should be solid lines, and as I'm looking through, everything here is solid. So that's a good start. The next thing I would do is, I guess, individually start graphing. So this first one, y-intercept of 3, and so let's start at 3. 1, 2, 3, right there. The slope is 1, so I'm going to go up 1 over 1. All right, so that seems to work. I would pick a test point here of, let's say, of 0, 0. Okay, so let's see, this would be 0 is less than or equal to 1 times 0, or 0 plus 3. So is 0 less than or equal to 3? Yes, it is. So that's true. So I should have shaded on this side of the line, and it looks like they shaded up here. So A is out. So let's see another one that could be eliminated is also D, because you can see it's the line looks like it's graphed correctly, however shaded on the wrong side. So that is out. So the next thing we need to do is look at the second inequality, and so that's gonna let's see, start at -2, because there's your y-intercept. So looks like they both start at -2. Right, so there's that. My slope is going to be -2 over 1, so you go down 2 over 1. All right, so down 1, 2 over 1. You can go in reverse of up 2, left 1. All right, so the line is graphed correctly. Looks like on both of them I just need to check my test point, 0, 0. So if I put in 0, 0, I would have 0 is greater than or equal to a -2 times 0, and then minus 2. So I have 0 is greater than or equal to 0 minus 2, or -2. That is a true statement, and so you would shade on the side that we picked the test point on, which happens to be this side. So we would definitely shade here. It looks like C is the correct answer, because down here on B, they shaded on the opposite side, which is over there. All right. Another option that you could use here is to simply plug both of these into your graphing calculator, your TI Nspire, and just remind yourself that you want to change your equal signs into inequality symbols, but you could graph these, and that would be maybe a little bit faster than what we just did. All right, that takes care of this question. Please stay tuned for the question that follows. Okay, let's look at this next example. It says graphing inequalities and determining a solution point. The graph of an inequality is shown below. Write the inequality represented by the graph. So I'm going to need a couple things here. I'm going to treat this like a linear equation. So I would need the y-intercept, which is a -3. I would also need the slope, which is going to be a rise of 2 and a run of 1. So rise of 2, run of 1, and will be 2. So I'm going to have, in terms of y equals mx plus b, I'm going to have a 2x minus 3. Okay, I would have a y here. Now my symbol, my inequality symbol, is going to be looking at either greater than or equal to or less than or equal to symbol, because it's a solid line. Everything here that is shaded looks like it's above the line. I'm going to guess that it's greater than or equal to. Okay, so 0 is in the solution set, which means 0 should make this true. So 0 should make what I have just written true. So that would mean 0 is greater than or equal to 2 times 0 minus 3. So is 0 greater than or equal to -3? It is true, so I know that is actually my answer. Now let's go with the next part here. The next part says to graph the inequality x plus 2y is less than 4. Well, in order to do this, I'm going to subtract the x over. I would have 2y is less than -x plus 4, and that's a -1x plus 4. And if I divide by 2 everywhere, I'm going to end up with y is less than, and it stays less than because I did not divide by a -2. So -1/2 x plus 2. All right, so start at 2. There's my y-intercept. Slope is -1/2, so I'm going to move down 1 over 2, down 1 over 2, down 1 over 2. You can go in reverse if you would like. All right, now this is a less than, and so when I go to graph this, I know that I'm going to need to have a dashed line. So bear with me here. So we'll make that into a dashed line. So that just means that any ordered pair as a solution cannot be on that line. All right, so there is my inequality. I'm going to label that as y is less than -1/2 x plus 2. Now, let's see. Shading this, pick a test point. Let's pick 0, 0. Will 0, 0 make that true? So go down here. 0 is less than -1/2 times 0 plus 2. So is 0 less than 2? It is, so I would shade on the side of 0, 0, so down here. Alright, so pretty much anything in this region would be considered a solution as long as it's not on this dashed line. So down here it says the two inequalities graphed form a system. Oscar thinks that the point 2, 1 is in the solution set. Is he correct? Well, 2, 1 is 1, 2, 1 right here. Almost in the solution set. It would be, except for the fact that this is a dashed line, so it should not be included. Therefore, Oscar is wrong. Thank you. Please stay tuned for the question that follows.